Hello, boys and girls. It's me, the Guide Knight, and welcome to part 5 of my Breakout tutorial game. Last time, we made sure that the player has a variable length, so we can make it very, very long if we want to, like this, or we can make it very, very short, like this, by just changing one small property in the Inspector tab. Let me try that again. In the Inspector tab, and we can have a tiny player. So now what we are going to do is actually change the player length to 7 because it's a normal variable, I think, normal like length. And also we will make sure that the ball bounces in the correct direction, right? Because right now it's very monotonous. You see that independently of where I hit the ball, it just goes in the same exact vector that it had on the when it hit the player, it just bounces the vector. And this is exactly what we're doing also in code. So it's not unexpected, but it doesn't have any space for player skill that they can use and hit the bricks and destroy them. So let's do that. How can we do that? The first thing we have to let's first try to think about how we can do it. Like we go to the ball script where we change the direction. We have the collision here, and we change the direction with the bounce. What else do we have in the collision? Let's go to the kinematic collision today and see. Okay, we have the normal of the and we have the collider. This looks interesting. This is the colliding body. So this means that the colliding body is either the player or the wall. We can test that hypothesis by simply going to the ball and printing out the collider, right? Print. Let me show you how we can actually concatenate a string and an object. Like if I do plus collision collider, let's say, I'm not going to do that, collider. Let's see if it will work. Oops, it doesn't work. It says you cannot concatenate string and object operator. So what you need to do is type str for short for string and put those thing in brackets. Then basically, if I run it again, it should work. But without the plus sign, instead of the plus sign, we're going to use a comma because this is kind of a method name call. So now it works. So you see kinematic body 2D and then the tile map. It actually collides with the tile map and it collides with the kinematic body 2D. So we need to only change the direction when it collides with the player. So we can simply say, okay, if it's a kinematic body 2D, then it is the player and that and that. But maybe in the future we'll have additional kinematic body to this, or maybe you need it for a different game and a more like precise way of defining who the player is. And maybe we also want to share other properties, not only if it's the player or not the player and so on. So how we can do that? One of the ways to do it is to use a singleton. We are going to do this way right now. We're going to learn about singletons and we're going to use this singleton object we create to check if the player is colliding with the ball. So how we can create a singleton is we go to the player folder in the file system, right click and add a new resource. So for the singleton, we're going to use a simple resource, just add the resource, normal resource, and we'll call it like player container. This is what we're going to call the resource. Save it, click the resource with double click, and then go to the script. In the script, you create a new GD script. Then you can click again to actually open the new GD script, and we can start typing, right? We first extend the first thing is the extends keyword, which says this script basically is in the hierarchy extending from the resource node. So extends resource, and then we'll also define the class name. Class name player container. So we can now save the script, but for some reason it doesn't actually ask us what to save it as. Let's see if we can figure that out. But for now, we're just gonna add the variable player. It is gonna be null. This is in this resource or in this singleton, there will be only one object or one instance of the player, and this will be this variable. But the variable will not be set from inside the container, but other objects will actually take the container and set the variable there, basically. So let me try to visualize that a little bit, how it will work. We have here the player container, which is our singleton. It's only one for your game, or for that's why it's called singleton, because it's only one instance. And then the player instance, the player object, will set itself, like it will define the player, set player. And then other, like whatever objects can use the player, like get player, and so on. Like one of those objects will be the ball, right? Maybe in the future we can also have other objects. But this is the way it's basically working. They can statically instantiate or preload the player container, and this player container will already have the player set by the player itself from the ready function. So this is how things are gonna work. And let's do that. And also one other thing, let's define a variable called player width, just player width. It will be the player width in pixels. This we will find out why we need that during this episode. For now, let's save it and see why this is class name isn't allowed in built-in scripts. All right, so guys, I will just create a normal script. Like I will copy or cut out everything out of here, go to the player folder and create a new script, call it player container GD, and paste everything. Of course, this didn't work. Okay, for some reason my pasting is not working, but I can just quickly type it in again. There we go, magically it appears. And now I will click the player container resource, clear the existing resource, and then load the player container script I just created. This should do the trick. How can we instantiate the player here? We can do that by going to the player script and making sure that we define a constant. Like we can define a constant player container, and then we're going to use the preload function, and then we're going to preload the resource. So I can drag and drop the resource here, so it is preloaded. And this is enough actually to access the player. So I can go into the ready function, do the player container dot player, and then assign self to it. So I am assigning the player to the player object inside the player container. It's a little bit confusing, but it is what it is. So self reference is basically, in some other language is called this, for instance, in Java or like other programming languages. I think in Python and GDScript it's called self. So, and I'm also going to directly instantiate the player width, right? What is the player width? The player width is basically the left side of the player, and then we have the middle side, and then we have the right side. In this case, the player has like player length of 5. So player length times the individual cell width. We can directly go to the player itself. We can open the player in the 2D world, or actually it is defined inside the tile sets, so we can actually go to the player tiles and see how much is the width. It's 24, so it is basically 24 for all of them, and that is something we can use. So we go back to the script, and instead of typing 24, a magic number, we're gonna just define another constant and call it player cell width equals 24. So this is the pixel width of each individual player cell. So we have the player length, which is the cell length, and the player cell width, which is the individual width of each cell. So now that we have defined those, we can actually use them in the bow script. Like we can simply copy and paste the player container inside the bow script. And I'm gonna do it. I'm gonna paste the constants above the variables and onReady just below the export. So I like the export and then the onReady and then constants and then variables. It gives us some order. So here in the collision, we can check if player container.player, or let's do it the other way. Like if collision dot collider equals player container.player, right? This means that the colliding object of this specific collision we are detecting is the same as the player. We can simply print collider player, right? And we can also leave the other one just to make sure it is the same, right? We are always colliding with the same kinematic body 2D. Okay, we no longer see the collisions with the walls, which is something that we definitely need. All right. So now let's actually think about how we can define the position of the ball. This is a little bit trickier, guys. So I'm gonna try to draw it again, and hopefully you can get what I mean. So we have our player here, right? Like player, and has a position. This is player dot x because we're only interested in the x-axis. Here is plus, and here is basically minus. It's like lower and higher. This is the position of our player, right? Player. And then we have the ball that collides with the player somewhere. Like this is the collision position. Collision.x. This is the collision position. I'm gonna remove this arrow because this is very confusing, and make it from basically I can make it from below somehow because it's this would be the bounce arrow, right? This is how the ball currently bounces. What we actually want to do is we want to make out of this basically an like we would like to have a division, like from here to here. We would like to have -1, 0, and 1. This is our end goal, because what we actually want to have is if the ball hits here, independent of the income vector, we always want to have the same outgoing vector, which is that one. Here, the outgoing vector will be that one. Here, the bounce vector will be that one. You get the point? The closer we are to the middle, the closer we are to 90 degrees. And the closer we are to the edges, the closer we are to basically 0 degrees or 180 degrees. So, yep, this is how we want to define our bounce, depending on where the ball hits the player. And this will enable us to have some skill and actually predict always where the ball will bounce off to and hit the bricks repetitively. So how can we get here? Like, and maybe it will be a little bit easier later on when we actually implement it to see why we need the -1 and 1. But it is what we actually end up needing. So we have the global position here. This is the player global position. We have the global position of the collision. And if we actually do the collision global position minus the player dot global position, we will get the relative position, right? This is the relative x position. So it means that it is in pixels from here to here. This is what we are actually getting, this distance in pixels. And let's call it relative Rx. And in order for us to get a percentage value from like 0 to 1, then we need to divide the relative position by the total position, right? Total x or total position. So like in that case, to be relative x divided by total width. Actually, let's call it width. To total x is a little bit misleading. So this will give us a range between 0 and 1, right? This is what we're gonna get. And if you want to convert this range to a -1 and 1, we can basically subtract 0.5 from this range. Then we will have a range from 0.5 minus 0.5 to 0.5. And we can multiply it by 2. And then we will get a range by -1 to 1, right? This is our end range we are aiming for. So I'm not sure if this made it a little bit clearer or not, but let's implement it and maybe things will get clearer there. So first of all, we're gonna have like if else, and we're gonna retain the original bounce we had in the case where we're not hitting the player. So where we're hitting the wall, we want the ball to bounce exactly as it bounced before. And we also want to have the y direction. Like we don't want to really touch the y direction. It's the up and down direction basically of the ball. So we will first start with a normal bounce. Like this is the normal bounce we have of the ball. And then we actually would like to change the direction only in the x value to be equal to get x bounce direction, right? Or yeah, get x bounce direction should be all right, and we will pass in the collision. So let's create this function. Function get x bounce direction collision, and the collision will be of type kinematic collision 2D. Kinematic collision 2D. And for this, we first need to define our relative position, right? So let's call it var relative x is equal, the relative position is equal the collision position minus the global position of the player. So collision dot position dot x. The collision position dot x is basically we can yeah, it is the global position, the point of collision in global coordinates. Yeah, so this is what we're getting here. Collision position dot x minus player container dot player dot global position dot x. So now we have our relative position. The total width of the player we actually already have. It is player container dot player width. This is like the total width of the player. So the next step of our equation is to divide the relative position by the total position. So this will be like, let's call it percentage. Percentage is our relative x divided by the player x, by the player width, right? So collision, okay, I need to type in correctly the name of the variable, otherwise it doesn't work. And in the end, now at this point we have from 0 to 1 basically. If it hits it in the 0th location of the player, then basically it will be 0, and it hits it in 1 location of the player, it will be 1, exactly 1. So we need to subtract 0.5 and multiply 2 to get the return coordinate, right? So let's just return and then do percentage minus 0.5 and then times 2, right? So right now we should have minus. This should be in the range of -1 to 1, right? And this is the direction we want, right? We want to have some direction that is capped to 1 and is from -1. Okay, but what could happen right now is that it can be not it can not be normalized. Like it can happen that the whole thing is let's say we have the coordinates here, and then we have the circle, the normal circle, which is like with 1, 1, -1, and -1 coordinates, basically goes through those. And usually the direction is a vector inside this circle. But right now we are retaining the y. We are retaining the y basically coordinate, but we are changing the x. So it can be that the x is a little bit longer or a little bit shorter. So we actually need to normalize it to get consistent speed, right? Because otherwise the speed may be a little bit faster, a little bit slower, and that's something we don't want for our bow. So let's normalize it as we did here. Actually, we already did normalize it once. So maybe as we already normalized it here, maybe we don't need to normalize it again. So this definitely is something we can consider, and it seems that it's always first normalized, so I don't think we need it. Just I mentioned that so that you know that actually this is very, very well needed. So now let's test, guys. This is the moment of truth to see if our efforts paid off. So now technically if the bow hits the right space, it should go to the right, and the left area should always go to the left. So far so good. Let's try to go right. Yes, this works. Now let's bounce it left, right. See, it's much more predictable, and you can actually use it to target some tiles, some bricks that oh, look, our player, if we hit it in the very edge of the player, it went down. So it went down again. So let's fix that. It's a very easy fix, actually. We can make sure that in the physics process, we always like apply a y position. Basically, function, or let's call it fix y position. It can be just the normal function that does position dot y equals 0, or not 0, but let me look actually inside the world. What is the original position? The original position is 736, right? 736. So position equals y equals 736, and then we can hit as much as we want, but it actually will no longer go below the ground. So guys, I hope you liked this episode. I think we're very, very close to actually adding the bricks in and making them disappear and so on. So stay tuned for more of this tutorial. And if you did like it, I would very much appreciate if you gave me a thumbs up. And also you can leave me feedback, what you would like to see if you don't understand something, or if you think I'm doing way too much explanation, you would like to proceed a little bit faster, or I'm doing under explanation and basically some things are still unclear. So I would very much appreciate some feedback, guys. And thank you for watching. Stay safe, stay cool. I know you are. Stay awesome. And that's it, guys. Bye bye.